Namaste, sir.
So today we have Professor Arpan, and Professor Arpan is going to give a brief introduction about the nanoscience, especially nanoparticles. And so, please, sir, give some information, and then we will start our conversation about give some information about the working area in research.
Thank you very much, Professor Tiwari. Generally, my broad research area is nanomaterials for energy and environmental applications. And yes, it's a good question that about why like all world also now moving towards nano. So how we can explain these nanomaterials? So usually also whenever I also try to give some lecture or I try to deliver a talk about this, so I also try to explain this in a simpler way so that everyone can understand this. So I will always try to explain this by taking the examples which was related to us or which day-to-day life we are using. So based on that, I try to explain. So the same example also I will take it here. So mainly, I always try to tell that why really nano means what means somewhat smaller size. So really, if we reduce the size, whether it will enhance the activity or enhance any application, if we are going to uh, carry out for energy or environmental, whether we will get enhanced application if we reduce the size. So that is a very big question marks. So whether it's possible. So for that, I will take a basic examples. So in day-to-day life, we are generally doing. So suppose, sir, we will prepare a curry. So in the market, we try to buy 100 gram green chili. So that 100 gram green chili, 20 gram each, I try to deep separated out it. So 5 different places I kept 20 gram each of that green chilies. Then we will try to prepare a curry. So we will use those 5 different places we kept 20 gram each. So all this will use to prepare 5 curries. We will prepare 5 curries by using this. Rest of the all the parameters will keep fixed. Temperature, time, everything will keep fixed. But we will only check that green chili, that same amount everywhere, 5 places we kept, that will take it. In one place, one time, we prepare the curry. We take those green chilies as it is and we put it on our curry and we make the curries. In another time, we will prepare the same curry that we just try to cut it 2 pieces of that green chili. We try to piece 2 pieces and we prepare the curries. Third time when we prepare the curry, so another 20 gram will take it, but what we will do, rather than 2 pieces, here we will make it 4 pieces. Another one, we try to make with 8 pieces. The last one which we will take to prepare the curry, rest all the same, I'm just cutting the green chilies. The last one, when we try to do it, this time we will not cut it. We try to make a juice by using some mixer grinder. We try to make it juice and we prepare the curry. So, sir, in the 5 different places, so, sir, the taste or spiciness, whether we will get different, sir, or we will get same, sir.
Different, sir.
Definition, where is, sir, get more spicy?
I think in mixer
Grinding
grinder.
juice, sir. So,
Yes.
so definitely when we juice it, that we will get more spicy. So what exactly we did? We did not did anything. What we did exactly? We just reduced the size by cutting it several pieces. The first green chili we take, as it is we take, then I reduce, then after I reduce, I reduce. So means the reduced one, here you can understand that the taste, when we are testing the tongue towards this, so reactivity increases. So means if we reduce the size from this basic example, it is clear to us, to everyone, that if we can reduce the size, then here reactivity, surface reactivity or active sites, all these things will increase or enhanced. So if these active sites will increase, then definitely our performance will be enhanced. So that is the example which we can correlate that nanoscience with respect if we can take some micro or milli or meter scale.
Wonderful, sir. Wonderful. So, sir, can you please give little more elaboration that how these nanomaterials are affecting the real-time application in science and engineering?
Yes, definitely. So definitely. So here we can from this example we can understand that that if you can reduce any material, we take it. If we can reduce it, then definitely its activity will increases. So now, why this activity increases? Then definitely from this we this one. The first of all, the first important point, that is the surface to volume ratio increases, and then that is the most important point in nanomaterial. The surface to volume ratio increases, and the second important factor, quantum confinement effect will occur, and then also defect will be very less in this case. So now if we go to the application part, in the application part, if we go to for the several application, definitely several factors plays important role. So any application, if we consider the different application have different fundamentals, kinetics will be there, or fundamental rules will be there. Based on that, it plays the role. Somewhere like if band gap plays an important role in some applications, if band gap plays important role, means quantum confinement plays means quantum confinement, or electrical conductivity will be also changed if we reduce the size, because we can understand the color, the different color if we get. So color gap, color different color if we get, then definitely its band gap will change, because color is directly proportional to the band gap, the wavelength.
UV properties is getting changed.
It will be changed. So there will get a different properties. And so then definitely in that related applications all will be changed if we can reduce the size. Then in other cases, in other application, if you take like the hardness in mechanical property of the nano, we all know about that diamond is the hardest material, right? But that is wrong. The carbon nanotube,
Graphene, now graphene, now graphene.
yes, so has the strongest modulus of elasticity. So that again, there is again a different thing. We can able to tune this one with a different, like sometimes it can behave like semiconducting behavior, sometimes it behaves metallic behavior, sometimes insulating behavior. It can show the carbon nanotube, three different properties can be tuned by doing the tuning the wall, and by tuning the arrangement of this hexagonal atom where they bonded together. So by the like armchair, like several types of carbon nanotubes, armchair, or we can say about the chiral or zigzag. So
sir, one more question.
yes,
so these how you are using these nanoparticles or these nano modification in your research particularly?
yeah,
So please give a
yes.
brief introduction.
Yes, very nice questions. So generally, that the first difference I did not tell. If we take any micro or any milliard or any material which you can able to see that we want to take it, that is called bulk material. So all are three-dimensional in nature. Three-dimensional in nature. Any bulk material take, that is a three-dimensional nature. But the beauty of nanomaterial, that we can tune the dimension. We can make it 0 dimension, we can make it 1 dimension, we can make it 2 dimension, and the 3 dimension generally we can also make it 3-dimensional structure. So based on that, we can tune the dimension. So my aim will always, our aim is we have to change the dimension, the orientation. So change maybe 1-dimensional structure you can make, 2-dimensional nanostructure you can make, or 3-dimensional. Then based on the dimension, we try to check our applications. Suppose I need, in particular in water, if I consider I have several I usually doing several applications on water splitting or energy storage applications, or in that fuel cell applications. So based on that, suppose in one case I am interested that the conductivity should be much good, or electron transport property should be higher. So then if I can make it one-dimensional structure like nanowires or nanorods, then what will happen? Then electron transport becomes faster compared to 2D sheet or three-dimensional structure. One-dimensional structure, electron can transport very easily. So based on the applications, first our aim will be we have to tune our morphology or tune our the nanostructures. So we tune,
Understand.
and then that we can use for different applications.
Perfect, sir. Perfect, sir. We will, sir, keep talking, and when I will get time, actually, it's a lot of work. I'm busy, so when we will get time, we will keep talking on this subject, and we will keep making our audience aware about this.
Yes. Thank you very much, sir. So you also, yes, definitely, and also in future also we'll try to do some like recent papers, like
Papers, yes.
recent papers on nature and these that also we try to discuss, so
Yes,
that
yes.
it will the viewers can also get knowledge about that. We will also enhance our skill.
Yes.
Thank you
Okay.
very much, sir. Thank you very
Okay,
much.
thank you, sir. Thank you, sir.